Why you're
This is a
those?
virtual background, and I'm now at home.
Mm,
So yeah, today I'm going to talk about the ML Python binding and trouble when I dealing with the Python binding for MLIR. First, to create a Python binding for ZKD types, we didn't use something called the um the beautiful the framework for Python binding. We just add API manually, but for advanced usage, we typically use PyBind 11 or NanoBind for that, and which means you are going to create a Python extension based on many C-purpose library, basically. And there could be a problem if you our project is so big. The and to solve this problem, we typically the X-ray or TensorFlow or JAX suggest us to use something called PyRep. So what is this for? This is for so if you don't use PyRep, it says that we typically ends up with violating something called ODR rule, one definition rule. And if you use PyRep, this is a kind of overview. So if you have a C purpose library called A, B, and B and C, and this PyBind extension, let's say we don't use PyRep, just say that we create an extension based on A and B, and we create an extension B based on B and C, and Python library A depends on A, Python library O should be B. B depends on extension B, and we create a one big gigantic module from this, then we could potentially meet some problem because of this B. Because so there's something called ODR rule, one definition rule. There are some exceptions. If you go into this link, there are some several exceptions, but except for these exceptions, C++ assumes that there's only one object per symbol. But if B, the inside the A and B inside the B have a different layout, it could potentially cause you some very critical problem. So when does it happen? So let's say this module A is built with optimized mode, which means the pack struct is not defined. And let's say module B is compared with the O0, and which means this is for O0, I guess this is for size. So that's why pack struct flag is on. Then what can happen is like, let's say we have this struct and module A, we have a symbol data config of this size, which is 12 bytes. But module B, which has a symbol of data config, but the size is different than A. Then this is one typical example of ODR violation. If we have this different different object with the same symbol, then we can lead something like undefined behavior or kind of data corruption or for some time. So to prevent to prevent it from happening, they provide us some rule, something called PyRep, PyRep, which has two mainly used the macro. One is PyBind extension and PyRep library. And if you use PyBind extension like that, then it automatically kind of flatten all your dependency, and it tries to link at this stage, not at this stage. Previous solution tried to link at this stage, so could this CC library could make you conflict, but if you use this, if you depend on use rule, then linking happen at this stage. It just give me the dependency list in a Bayesian syntax. So we need to use that. And now, actually, I have I should have read the README first, but I just go and I use Python extension only, and every time I try to use some symbol, it's always say that, oh, you don't have this symbol because I didn't link yet before this day. So if you stick to this pattern, then you don't have to care about the details, but it just works. So that's how it is. And now I'm going to talk about Python binding for how we can do a Python binding for MLI type or MLI attribute. Oh, is there any question up to this topic? No? Then, okay. So before anything, you should first register your dialect, or you should expose how to register your dialect in C through the C API. And that's going to become a Python API later though. So first, you need to provide this header, which have this macro. MLI declare C API dialect registration, field and field. And this give us make a C function declaration like that. This will going to be field. Oh, wait, name, where does name used? I think it's just a empty placeholder for this, I guess. This is not used in anyway. Yeah. So if you use this, then we get the function declaration like that. And now in the source file, now you need to do a MLIR define CAPI dialect registration with these three arguments. Then we get all of these. Then from Python binding side, to register your dialect, you need to expose register dialect API. And these APIs typically provided by PyBind 11 or Nanobind. We are now using a Nanobind. So now, from Python API side, using that, you can register your dialect. Now it's good to go. But the problem is like, so how can we put my thing? Also, so now that this module has a fit mode.cpp, and we need to locate this library at this position, right? Then how do we do this? And this is also going to be described in below section. And this is also another problem to me. Takes me few hours just to locate everything at the proper position. And for field type, the same. You need to first define CAPI and then Python binding and Python API. So first, you need to declare, actually, this is header. In header, you need to declare this API to be used by Python binding. And I think type and attribute are same. So this kind of get type ID is all something, type get, all of that are used by default provider. So sorry, for first two things, for every type binding, every attribute binding, you need to put your implementation for isa function and get type ID function. So regardless of your type or attribute, the first two are mandatory to expose. So I create that. The third one is how you create a CKIR or your type based on Python argument. And this is going to be used by this. So field.profit type dot get with this Python argument. Now you create your type in C, and you will return it as a Python type. This is how the get works. And for the rest of two are the C API for to retrieve any field from your private. Our private has a modulus field and is Montgomery and Boolean field. So I expose these two APIs, and this will be retrieved by this read-only property. So this, if you have a Python private type, now you can return modulus attribute and Boolean of its Montgomery. And as you saw in yesterday, I actually uploaded two issues because of that. So one issue is regarding this. So I wanted to use pi integer attribute here instead of pi attribute because now I need to handle that. So this attribute could be Boolean attribute or could be array integer set attribute. I don't know what attribute come in, but if you can use pi integer attribute, then this nanobind framework guarantee that only the integer attribute come into this place. Otherwise, you will get the like casting error just like naturally. But now I can use this because this pi integer attribute is defined in source file within an anonymous namespace, so that I cannot include this class from this file. So one issue is that you need to make a change to LVM, that you need to construct the Python type like this. So you need to create a declaration for your Python type in header so that I can bring it, and only the definition should be located in source file. Otherwise, I can get this into my custom type. That's one problem. The other problem is, so pi, if you look at the definition of how the pi integer attribute implemented, oh, not this. Okay, I'm talking about the same issue. Okay, so because of the same issue, I can return pi integer attribute. So I needed to return pi attribute. I think because of that, I really wanted to use a int casting method declared in pi integer attribute, but I couldn't use this. So because this pi attribute doesn't implement integer casting operation, so that this is not allowed. So if I can bring pi integer attribute instead of pi attribute, yeah, this allowed me to do this. That's a problem because of this issue. Another issue is that, so this integer casting operation only allows us to casting to integer value up to 64-bit, which means I can use this for BN254 prime field. So, which means I only can use Python binding for only the prime field that puts modulus up to 64-bit. That's my situation. And
so, can I ask a question?
yes.
So is it the casting problem or is it the pi integer attribute problem?
Pi integer attribute problem.
Okay.
Pi integer attribute only casting it to up to 64-bit. So we need to also add a patch to LVM.
Yeah. So that sounds like it is the casting problem, not the pi integer attribute.
Yeah, casting of the pi integer is kind of limitation.
So yeah, I mean, so can you actually store large integer inside pi integer attribute? I mean, I get that the casting will not work properly, but
I think it's possible because, so for example, so anyway, pi long can hold arbitrary big multi-precision integer also when you create a pi integer attribute, it just you can create pi integer attribute based on pi long instance, so that you can retrieve, for example, big int from this pi long, and then maybe you can convert it to AP int. But anyway, the interface between this pi integer attribute and integer attribute, they don't use AP int. They just only use int64. Yeah. So from a Python API side, this is a way to create a private type. So an integer type and integer attribute is belong to IR namespace. So maybe you could write it as a IR integer type or IR integer attribute. But anyway, you can first need to create an integer type first, and then using that, you need to create a modulus attribute. Using that, you need to create a private type like that. So attribute is basically very same. So you need to follow the same order. First, you need to create a C API for attribute. These two are same. Three also same. For the third, you need to create a C API to how to create your attribute based on Python argument, or C argument based on Python argument. And then the last four is like, so if you want to get anything from your attribute, you need to create a C API for that too. And these are same, just these are different. I believe PyControl add 3 or maybe same or could be different. The looks very same. So if you follow this same order, then you also create your custom MLIR attribute. The last question, the last challenge was like Python package location. So first, two orders are almost same, but yeah. Anyway, if you create so as I mentioned earlier, operations could be created automatically from ABGen. Then you will get the underscore field underscore ops underscore gen.py, and we'll expose this file from, because here, as I showed you earlier, I want to expose field under dialects namespace. So this dialects slash field.py will expose the automatic generated symbol under these names under this Python file. And as I mentioned earlier, how do you expose this Python module? How do you put this binding to here? The answer is this. So you're going to put underscore field.so. So you're going to put underscore field.so is under some certain location. We didn't specify yet, but we should put this and put it the same under same directory first, so that you can use function or function defined in the C extension, and function defined in this file could be used by importing dialect fields. And the problem is like chaining kind of. So if you put this like that, so this underscore field field of genpy, try to import at the same position something called oldest common. And these oldest common file are defined in LVM project at this position with this baser target. And this guy also trying to import MLIR libs and IR from a parent. So, and this guy, MLIR /IR, yeah, Yeah, as I mentioned, this is under the same directory, so it's fine. But so anyway, if you collect all the information, then we need to have something like this structure at some certain location. It doesn't matter where all these files belong to, but anyway, all these files have a kind of relative relation like that. So for example, like dialects.field.py should have a sibling relation between field of GenPy and ODS common pi. And all these are, I mean, originally they are root from a different, complete different position. For example, like, so yeah, I mean, this guy I created myself, but this guy is not the one that I create. So how do we put all this together in a beautiful way? Otherwise, you need to manually copy and paste. And we want to avoid that, obviously. Then how do we do this? And this is the purpose of the symlink input. So in ZKIR, MLIR package, at this package, you're going to have a, because you're going to have a, so what was that? I think that was oldest common pi. So we're going to put dialect core pies, dialect core pies. Yeah, oldest common, yeah, oldest common. So if you do like this, what it does is like it going to put ODS command.py into MLIR dialects. So these feed files is put feed.py and feed of genpy under here too. Feed.py, feed of genpy, so that it satisfies all these rules. And here, it's a way to create a IR. I mean, create an extension. So let's forget about that. And for IR, you put IR.py here, MLIR/IR.py, like that. And this is the target to make this. So if you using that, if you put all this at some certain position sticking to this structure, then yeah, basically this kind of at this location you can import. And yeah, all these are located by satisfying some certain relationship, and yeah, you're good to use. And the last issue for me right now I have is like, so for Mac and Linux, it behaves differently to link for regarding linking. For example, on Mac, if I don't add this dependency, like here, it will give me this linking error. So it couldn't find this symbol. So I need to add this. But for Linux, if I add this as dependency, then it says something like this error. To mitigate this issue, I use something like this. So if it's Linux, I didn't add. If it is Mac, I think it's on the other way around. Condition differ. Conditions differ. So if it is differ, I didn't add. But if it is Mac, I added. This is I solve this issue, and this is so because I have to have a select at this position. Yeah, that's all. the recent PR in a GKIR, and I think now I'm ready to link DR types to MLI types. So in the meantime, I try. Yeah, if I've. Oh, do you have any question?
Nope.
Yeah, I stop recording then.